Today we want to determine the direction of concavity. What is concavity? A differentiable function is concave up if the first derivative is increasing throughout the interval, and f is concave down if f prime is decreasing throughout the interval. There's a convenient test for this. Given a function whose second derivative exists, then if the second derivative is greater than 0 everywhere, then f is concave up. And think of the idea of a graph that will hold water. If the second derivative is less than 0, then we say f is concave down, or the graph would spill water. Let's look at a specific example. F of x equals 2x squared minus 3x plus 7. We want to determine its concavity. We first would take the first derivative, which would give us 4x minus 3. Then we take the second derivative, which would give us 4. Notice 4 is greater than 0. F double prime greater than 0. So since f double prime is greater than 0, so we say it's going to be concave up. Concave up. Let's pick a couple of points here that we can work with to sketch a quick graph. Notice if we select x equal to 0, 1, and 2, if we put 0 into our equation, 0 here, so we wind up with 7. If we put 1 here, we have 2 minus 3 is negative 1, so we have 6. And if we put 2 in here for our value of x, then we have 2 squared is 4, times 2 is 8, minus 6 is 2, plus 7 is 9. So we have our point 0, 7, 1, 6, and 2, 9. And we should have already recognized, because this has an x squared, that this is going to be one of our parabolas. One other thing we might find, if this equals 0, then 4x equals 3, so x equals 3/4. So that means that x equal to 3/4 is kind of an important value. Let's say if we put it here, then our parabola will look something like this. And notice where x equals 3/4, our horizontal tangent turns out to be, has a slope of 0.